Hey guys, all right, so this is Notes 1 Part 1. We're going to talk about exponential functions and how they look. So for here, an exponential function is of the form f of x, and it'll have something as your base, and the x will be in your exponent. So the main form that you should see is a times b to the x. So what I had for you is some example. The base b cannot be 1, okay? But your base b can be between 0 and 1, but it can't be 1, so I guess we should probably write b has to be greater than 0. Sorry about that. I'll make that change for next year. So when we graph and we take a look at transformations, the biggest thing that we need to remember is without any other transformations, any exponential function that you have will always cross at y equals 1. Okay, so this point at y equals 1, it's a y-intercept of 0, 1. We call that an anchor point. Okay, we call that an anchor point. And that point itself is going to help us graph. Okay. So let's just take a look at an example and just see what the graphs look like. So for example 1, we have f of x equals 3 to the x, and part b, g of x equals 1/3 x. So if I'm using my functions, okay, I have these numbers. I'm going to plug these numbers in for x. So 3 to the negative third, 3 to the negative second. I'm going to plug all these numbers in for where x is. And then I'm going to simplify. So 3 to the negative third, if you remember from negative exponents, that means you have to move it to the denominator. And then 3 to the third is 27. So 1/27. Same idea, 3 to the negative second. That's really 1/3 squared, which is 1/9. And then 3 to the negative first, that's 1/3 to the first, which is just 1/3. Okay. And then your zero property says that anything to the 0 is 1, so 3 to the 0 is 1. And then we can continue doing the rest of these. Okay, so 3 to the first is just 3, 3 squared is 9, and 3 to the third is 27. So when we have an input of these numbers, we get f of x, which is our output, if you remember from Algebra 1, so we get all these outputs. So what I want you to do is I want you to plug -3 all the way to 3 into x and finish g of x on your own. So go ahead and do that now. All right, so g of x should look like this. You should have 27, 9, 3, 1, 1/3, 1/9, and 1/27. So what I want you to do is I want you to take a minute and I want you to think about what you found and what do you notice. Okay, so go ahead and think about that now. Go ahead and do that. Okay, so hopefully the conclusion you came up with is that when you compare your outputs, when you have the same input but different outputs, these outputs are reciprocals of each other. So 1/3 is the reciprocal of 3. The 1 is technically the reciprocal of itself. 3 is the reciprocal of 1/3, 9 and 1/9, and 27 and 1/27. So if they're reciprocals of each other, let's see what the graph looks like. So we haven't graphed this yet, the exponential functions. So I want to take a look at the characteristics as well. So when you have an exponential function, you always have a horizontal asymptote at y equals 0. Okay, always, always, always. So horizontal asymptote at y equals 0. And then we can use our chart for each of these graphs to graph. So 0, 1 for f of x. When I have an input of 1, I have an output of 3. When I have an input of 2, I have an output of 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9. And then the other ones are a little harder to graph, so just do your best. But the main thing is this isn't going to cross the horizontal asymptote. So when you graph it, you're going to get really close to it, but you're not going to cross it. Okay, so that one is f of x. So now we're going to do g of x. So g of x also has the same point of 0, 1. But this time, when we have an input of -2, we have the output of 9. And we have an input of -1, and we get a positive 3. So this one will look like this. So now when we look at the graphs, okay, what do you notice? Okay, so that's what this question is asking. What do you notice? Okay, so I want you to think about that and then come back. So hopefully what you notice is that they are reflections of each other. So when you have reciprocals, the graphs, what you see are essentially reflections. So this is reflected over your y-axis right here. So a fraction as a base versus an integer as a base will create that change. So the purple one is increasing all the time from left to right, where the green one is decreasing from left to right all the time. Okay. So moving along, for notes 1, part 1, we have this example, find the exponential function for the graphs given. So again, we're going to use this form, our f of x, a times b to the x. Most of these problems, a is going to be 1. So we'll make that change down here too. Okay. So for part A, we're given a graph and we're given a point on that graph. And you can see the intersection, and we can assume that this intersection right here for part A is at 1. And then this point, they give us an x and a y value. So if you have an input of 2, you have an output of 25. Okay, so output of 25, input of 2. So you need to ask yourself, what squared would give me 25? And because this point down here is 0, 1, a is just going to be 1, so it goes away. We shouldn't really have any that are where a is different, but if we do, we'll talk about it. Okay, so in the questions at the bottom for part A and B, it says what input is given and what output is given. So our input here is at x equals 2, and our output here is at y equals 25. So when we do this, we need to ask ourselves, what is being squared? Okay, how could we solve this? Well, you know, if you're squaring something, you can take the square root. Okay, so b equals 5, which means that our equation for this line should be f of x, a, which is 1 here. Our base is going to be 5 because that's b, and then you're going to write x up in the corner just like that. Okay, so for part B, I want you to try this one on your own. Take a look at where it crosses your y-axis and what inputs and output you're given, so then you can tell me what the function is. Okay, so go ahead and do that now. So here, you should get f of x equals 1/2 to the x. Your input is 3, your output is 1/8. So when you plug in your information, you can take the cube root of b to the 3rd, or you can ask yourself, what cubed gives me 8? Because 1 cubed is 1. Doesn't matter that it's a fraction. What fraction with 8 in the bottom, like what is the cube root of 8? What cubed in the bottom would give me 8? And that's 2. 2 cubed is 8. So when we find b, we rewrite it as our function. Okay, so that's how I would think about it, like what cubed or what squared, if you're not sure about using your radicals. Okay. So I want to do some quick graphing practice. So with 1 and 2 here, it says sketch the graph by making a table of values of the exponential functions below, state the domain, range, and where the asymptote is located. Okay, so we'll do one together, and I want you to do two. You're going to do them on the same graph. So for number 1, you're going to make a table of values. So I keep mine simple. I don't like to do more than I need to. So I'm going to just make my t table just like this. And then I'm going to use, I like to use -2, -1, 0, 1, and 2. So then when I graph this exponential function, base 6, 6 to the -2 is 1 over 36. 6 to the -1, we get 1 over 6. 6 to the 0, we get 1. 6 to the first, we get 6. 6 to the second equals 36. So these are my inputs and outputs. Some of them I can graph, some of them I can't. But I should always have 0, 1 unless I have an a. So here, because we have the form a times b to the x. So here, a is 1 here. So if a was 2, we would multiply everything by 2. And we'll get there, we're just not there yet. Okay, so if a is something besides 1, then you would multiply. So now whenever I have an input of 1, I have an output of 6. So 1, 2, 3, 4, 5, 6. And that's about all I can graph here. I know that I have a horizontal asymptote at y equals 0, because that's always true. So HA at y equals 0. And then I can graph my exponential function going through the 2 points that I can graph. Okay. Okay, and it looks like that. So for domain, okay, from left to right, remember that's domain, your exponential function can be all real numbers. Okay. Now range, remember it's down to up. So you got to see where your range starts and ends. So because we have this horizontal asymptote at y equals 0, okay, this one won't cross it. So my range will start at 0. It won't include 0 because it's never going to get there. Okay. But it will go all the way to positive infinity. Okay. We'll go all the way to positive infinity. All right, so I want you to do the same thing for number 2. I want you to create your table like I'm doing right now. Find your values. Okay, find your inputs and outputs. So you can create your own inputs and outputs if you don't like my numbers. Identify your asymptote and identify your domain and your range. Okay, so go ahead and do that now. All right, so you have this table. I use the same number, so you should have -2, 16, -1, 4, 0, 1, 1 and 1/4, 2 and 1/16. So your domain is all real numbers. Your range is 0 to infinity, not including 0. You have an HA at y equals 0, just like our first one. And then this is what your graph looks like. Okay, so just let me know if you have any questions. Check what you have. We're going to keep moving. So this next part I want you to try on your own because we did one together already, or we did a couple together. You're going to find the exponential function whose graphs are given. Okay, so take a look at where they cross. Remember the form that you need to make sure you're using is this a times b to the x. If you look, a equals 1 for both of these. Okay, so you don't have to worry about finding too much. You just have to figure out the general function. So go ahead and do that now. All right, so for 3 and 4, 3, you should get your function is equal to 3 to the x. For 4, you should get that your function is equal to 1/2 to the x. So for 4, this one was a little tricky because you had to think about what raised to a negative number would give you an integer, would give you a whole number. So because of keep, change, flip, okay, so 1 over 1/2, 1 times, keep the first one, change the sign, and then flip your fraction. Because of keep, change, flip, that's how you get, because this is raised to the third, still raised to the third, this is how you get 8. Okay, so let me know if you have questions about that. It's just hard to visualize sometimes, so just let me know what questions you have about that. So I'm going to go ahead and stop the video here, and we'll do transformations in the next video. Okay, have a good night.